Before pulling off the ultimate Trojan horse heist in America, the CLAAS family had to save a starving continent. After 1918, Europe's harvest rotted in the mud. The culprit? A failing knot. American monopolies like John Deere couldn't solve it. Their machines shattered against brutal crops. But four brothers in a Westphalian shed realized the giants were fighting the wrong war. August engineered a floating jaw that breathed with the material. It was so bulletproof it kept them from starving during the 1923 hyperinflation, trading steel for bread. But that iron bankrolled a century-long rebellion, a saga of building illegal prototypes under a brutal regime, hijacking the Midwest in Caterpillar yellow, and forging an empire that now dictates the future of farming. The crisis had been building for over a decade. Back in 1913, the Northern European harvest window was notoriously short, sometimes just a few unpredictable weeks. Miss it, and the grain shattered on the stalk and rotted in the mud. A couple of weeks was all a farmer had. The machine, meant to beat that deadline, the mechanical grain binder, was failing at a rate nobody wanted to admit. Farmers across Germany, France, and the Low Countries were watching a massive chunk of their yield disappear. Not to weather, not to disease. They lost it to a knot that wouldn't hold. The cast iron billhook at the heart of every commercial binder would hit a strand of thick twine or a rigid sheaf of post-war German straw and snap clean through. That sharp metallic crack meant the harvest stopped. Parts weren't available. The window closed. August CLAAS and his brothers, Franz, Bernhard, and Theo, ran a small workshop building straw binders and milk centrifuges out in the soil of Klarholz, Westphalia. They knew exactly why these knotters failed. The American-style fixed jaw design dominating Europe was built for American conditions: consistent, pliable hemp twine and uniform dry Midwest straw. German post-war soils were dead. They produced thick, brittle, inconsistent straw. The local twine varied widely from one spool to the next. A fixed jaw doesn't adapt to variance. It hits thick twine, and with nowhere for the driving kinetic energy to go, the cast iron shatters. His fix was a jaw that moved. August first nailed down the principle in 1921, locking it in with patent 372140. It was his 23 patent, number 414212, that perfected the floating upper jaw and shielded the company for decades. Instead of a rigid mount, the upper jaw rode on a heavy spring-loaded pivot. If thick twine hit the hook, the jaw opened wider. If the twine thinned out, it clamped tighter. As that heavy grain sheaf shifted down the line, the mechanism used that pulling energy to yank the loop tight. The jaw breathed with the material, instead of fighting it. August nailed the geometry on that pivot. The angular tolerances allowed the jaw to self-correct for any twine thickness on the fly. No operator input, no changing drive speeds. When Professor Gustav Fischer presented the DLG findings down in Würzburg, he proved the CLAAS knotter ran flawlessly with any twine you threw at it. August proved the broken knotters weren't just a bad break in the field. They were a solvable engineering failure. The brilliance wasn't the complex parts. August built hammer-ready engineering into the design. If the mechanism jammed hard in the dirt, a farmer could realign the jaw with a standard steel hammer and get back to work. No mechanic, no waiting for parts. It was dead simple to repair, yet geometrically precise to manufacture. Copying it without infringing the patent meant building garbage. The big legacy manufacturers knew they had a problem, and the battle to dominate the European harvest dragged through the 1920s, hitting a boiling point right as 1923 hyperinflation tore through Germany. Paper money became worthless trash. The brothers kept the shop running by bartering heavy iron knotters directly for bread and raw steel. August didn't focus on expanding production. He fought to protect the one patent keeping them alive. The legacy brands had no answer, because the floating jaw wasn't just a minor upgrade. It was a completely different mechanical beast. The patent was legally airtight. It became the financial engine for CLAAS for decades. Competitors were forced to pay heavy licensing fees because they were desperate to replace the failing American fixed jaws on their own binders. The proof was in the dirt. At the trials, CLAAS pounded out sheaf after sheaf without a single popped knot or snapped hook. By the late 1920s, the knotter problem was dead and buried. The CLAAS brothers had the cash to prove it. But agriculture rarely stands still. As tractors gained power, the era of cutting crop to thresh it later was ending. The future was doing it all at once, the combine harvester. The fields were throwing a new curveball. Heavy American combines were rolling into Europe in growing numbers, and the engineers who built them had never designed for wet, choking grain. The wet crop failure exposed a fatal flaw in American combine architecture. Their longitudinal flow fed crop front to back in a straight line. That worked fine for dry material. Dense, wet European wheat didn't move like that. It clumped, wrapped, and choked the threshing cylinder to a dead stop. The machine fought the crop. August CLAAS saw this and realized the mechanical sequence was backwards. His fix was the MDB, the Mähdresch binder. Instead of jamming crops straight through, the MDB used transverse flow. Running off the tractor's PTO, that transverse beater had the brute torque needed to cross-mill damp straw against the grain instead of ramming it lengthwise into a solid wall. This beat down the wet tangle before it ever hit the drum. Before the MDB hit the dirt, nobody in Europe had cracked the wet crop code at the engineering level. CLAAS didn't just tweak a design, he gutted the logic of the harvest and rebuilt it. Then, Europe collapsed. When the German industry fell under the shadow of a regime, no one was exempt. CLAAS was forced to throttle back on agricultural iron and take on armament contracts for the war machine. The brothers knew open resistance meant death. Officially, CLAAS was built for the war effort. The main floor pumped out what the state demanded, and the books matched. The books lied, however, about what happened off-site, after dark in cold Westphalian barns. The brothers were building a massive tractor-pulled combine called the Super. Getting caught burning state resources on a farm machine was a massive risk, so they kept the project alive under the radar. The brothers smuggled heavy iron between barns, keeping their mouths shut, and built the prototype only when the inspectors were clear. They survived the war. The Super survived with them. This wasn't just a survival project. The Super used an L-flow system, diverting crop 90 degrees after threshing to spit it out the back. That geometry meant the rig towed dead straight. It killed the lateral drag that jerked competing tractors sideways and beat up operators all day. Pair that with a seriously advanced straw walker, and the Super stripped nearly every kernel. In the post-war hunger winter, that 1% wasn't a performance stat. It was survival. Post-1945 brought a new problem. German hardware was toxic. British buyers didn't want German iron, no matter how well it ran. CLAAS needed a backdoor. They found it in a British distributor, J. Mann & Son. They pushed CLAAS tech to Commonwealth farmers without broadcasting the German origin. All that mattered was the Super tore through damp Empire wheat better than anything else in the mud. Field performance won the argument. By the early 1950s, that ironclad performance rebuilt CLAAS. J. Mann & Son proved a smart handshake could push hardware across borders that direct sales couldn't touch. For the next decade, CLAAS owned the European harvest with a machine built in the shadows. Dominance breeds arrogance, and when arrogance outruns engineering, you get expensive scrap. In 1957, CLAAS launched a rig meant to completely rewrite how tractors and harvesters work together. It was called the Huckepack. The idea was a universal tractor chassis you could swap a combine unit onto, but the agonizing hours of heavy wrenching required to actually do it meant what guys found in the dirt nearly snapped a company in half. The Huckepack failure forced a reckoning. CLAAS didn't need a new savior. They had Walter Brenner. He wasn't some new data guy. He was the veteran mechanical engineer who originally cracked the code on their World War II machines. His pitch to the CLAAS family was blunt. You can't fix a combine's limits just by stacking on thicker, heavier steel. You fix it with smarter control. Helmut CLAAS stepped up to lead. He didn't need a pilot's license to look at a combine like it was an airplane cockpit. To him, it wasn't just a row of levers to pull. It was a live feed of data. He knew the machine needed a nervous system before it needed more horsepower. He started wiring the company's engineering mindset for that shift long before the actual hardware existed. When CLAAS rolled out the legendary new Dominator series in 1970, the real breakthrough wasn't a computer. It was brute force efficiency. It introduced a hydrostatic drive that let the driver infinitely vary ground speed on the fly. Hit a thick, damp patch of wheat, the operator could just pull back the stick to smoothly slow the hydrostatic transmission before the engine even choked on the slug of heavy, wet straw. It wasn't modern AI, but this loop, sense, process, command, laid the heavy iron bedrock for the CMOS platform they run today. The roadblock was cash. Building Brenner's sensors and circuitry took capital CLAAS didn't have after the Huckapack mess. For years, industry rumors swirled about a Soviet backdoor, whispers that CLAAS secretly licensed their designs behind the Iron Curtain to fund their R&D, but that's pure myth. The massive Rostselmash plant stamped out their own SK5 Niva combines by the thousands, completely independent of Western iron. There was no secret Cold War cash pipeline. Instead, CLAAS had to fund Brenner's tech the hard way, by betting the absolute survival of the company on the Dominator's success in the European market. Every Deutschmark pumped into sensor development was earned in the dirt, completely exposed to Western competitive pressures. John Deere and International Harvester calculated CLAAS's R&D budget based on those visible sales, but they fundamentally underestimated how much of that revenue Helmut CLAAS was stubbornly funneling straight into Brenner's automation lab. By the mid-1970s, the gamble paid off. The Dominator stabilized their finances, and CLAAS had working prototypes of throughput control no rival was close to matching. European harvesters had paid for the proof, and now CLAAS, armed with technology its rivals hadn't yet imagined, turned to face a brutal new reality: a rapidly shrinking industry and a North American market that had never once considered buying German iron. A shrinking industry demanded an aggressive response. In 2003, CLAAS delivered. When Renault spun off their agriculture division, CLAAS didn't wait for an auction. They swooped in and bought a controlling stake. Overnight, they grabbed a full tractor manufacturing operation, a massive European dealer network, and the Le Mans plant, a facility churning out iron since the 1950s. This wasn't a merger, it was a calculated strike. CLAAS secured exactly what they needed to stop being just a combine builder and become a full-line equipment heavyweight. Trouble hit immediately. The French crew at Le Mans didn't sign up to work for Germans from Westphalia, and they made it known. Labor relations in the early 2000s France were brutal. A wildcat strike would have choked the assembly line for months. CLAAS did something that looked like a retreat. The tractors kept rolling out in Renault orange. The Renault badge stayed bolted to the hood. For 2 solid years, a guy walking into a dealership wouldn't see a difference. Underneath that orange paint, CLAAS engineers were quietly gutting the internals. They swapped out the hydraulics for their own architecture and remapped the drivetrain logic to their own specs. And here's the kicker: those old Renault Aries tractors were running John Deere engines. While CLAAS was gearing up to wage war on Deere, they had to keep buying their rivals' power plants just to keep the French assembly line moving. This wasn't some black ops secret, though. CLAAS publicly announced the buyout and the strategic phase-out of the Renault brand. The workers kept their pride, the paint, and the name for a transitional period. In return, CLAAS kept the assembly line screaming and bought time to re-engineer the machines before finally pulling the trigger on their own seed green paint in 2005. While Le Mans simmered quietly, CLAAS dropped a hammer on the combine market, the APS system, or accelerated pre-separation. It completely changed how a machine chews through crop. Old conventional threshers relied on a single massive cylinder to beat grain from straw. Feed it too hard and the machine chokes. Separation quality drops. APS shattered that bottleneck. They stuck a dedicated accelerator drum right in the front of the main threshing cylinder. That violent spin generates enough centrifugal force to rip out 30% of the grain before the straw even hits the main cylinder. The main drum then feeds on a lighter, cleaner system. Guys running APS-equipped LEXIONs pushed massive volume without blowing grain out the back. The real monster was born when they paired that APS drum with twin separation rotors to create the APS hybrid system. When the flagship LEXION 480 hit the dirt, it chewed through a wet, heavy crop that would instantly plug a conventional machine. When you farm thousands of acres, leaving a fraction of a percent in the dirt means burning cash. The American Midwest was a tougher nut to crack. John Deere Green didn't just own the market share, it was practically a religion. A German outfit wasn't getting a foot in the door with a Kansas wheat farmer whose granddad bought his first Deere in '52. CLAAS needed a Trojan horse. They found it with Caterpillar. Under a new deal, CLAAS combines rolled onto American soil sprayed in heavy equipment cat yellow, badged as the Caterpillar LEXION. Cat supplied the dealer network, the deep trust, and the distribution muscle. CLAAS brought the iron. They didn't just float them across the Atlantic either. They built a massive assembly plant right in Omaha, Nebraska, meaning those yellow machines rolled into the Corn Belt carrying a built-in America pedigree. It wasn't just yellow paint. CAT dropped their own heavy-breathing diesels right behind the grain tank. That gave operators up to 400 horsepower and massive low-end torque to drag those tracks through the mud. The dirt-level performance did the rest. The TERRA Trac rubber undercarriage spread the machine's weight down to a mere 10.5 psi. That meant a CLAAS kept chewing through the muck and harvesting at 4 miles per hour, while Deere and Case rigs buried themselves to the axles. They could road at 18 miles per hour, but out in the mud, that flotation is what kept the headers eating. American guys who wouldn't be caught dead in a CLAAS dealership were running APS combines because CAT handed them the keys. The 20% jump in throughput wasn't brochure talk. It was hard data reading out on their yield monitors over the roar of the engine. CLAAS didn't smash the brand barrier, they tunneled under it. By the time farmers realized they were driving German iron, they didn't care. It simply outworked everything else in the mud. That North American foothold bought CLAAS the global volume they needed. The heavy equipment game was about to hit a brick wall that no amount of slick engineering could punch through. By the early 2020s, CLAAS hadn't just built better iron, they built a fundamentally different relationship with the tech running their machines. That relationship became a weapon. By 2022, the fight over who actually owns a tractor turned ugly. John Deere proved the reach of their software by sending a remote kill signal to stolen equipment in Ukraine, bricking those machines dead in the dirt. The proprietary firmware that let Moline pull the plug was the same lockout tech stopping farmers from turning a wrench on their own gear. CLAAS saw the backlash, but instead of starting a war, they joined the truce. In June 2023, CLAAS signed a right to repair agreement with the American Farm Bureau Federation, right alongside John Deere. It wasn't a wedge, it was an industry-wide reality check. They knew that if farmers couldn't get their hands dirty fixing their own iron, the entire market would revolt. That same year, the Hlavínka lawsuit laid CLAAS's new playbook on the table. Texas dealer Harvey Hlavínka sued CLAAS of America after they pulled his contract. This wasn't just a standard dispute. It proved CLAAS was actively gutting its old North American model, ditching the loose network of independent dealers to tighten their corporate grip. The brutal, drawn-out legal fight put every independent dealer in North America on notice. The old handshake days were dead. By then, CLAAS was a heavyweight. They had 12,000 people on the payroll, plants stamping steel from France to China, and were throwing punches with the two biggest agricultural giants on Earth. The Hlavínka suit was just the public face of a hard internal rule. No more sloppy dealer networks diluting the brand in a market they'd spent 50 years trying to crack. Then, the supply chain snapped. The 2021 microchip shortage bled out of the auto industry and choked every manufacturer wiring up heavy iron. Deere took hits across multiple lines. AGCO felt the squeeze. Modern tractors don't run on off-the-shelf silicon. They need specific microcontrollers, sensor arrays, and telematics modules, mostly sourced from a few fabs in Taiwan, South Korea, and Japan. When geopolitics and demand spikes slammed those suppliers at once, companies relying on single-source contracts watched their assembly lines grind to a dead halt. CLAAS saw the crack forming and braced for impact, relying on two fronts to survive the pain. Front 1, geography. Heading into 2025, 50% reciprocal tariffs on steel meant shipping a finished 45,000-pound combine across the Atlantic was bleeding cash. CLAAS already had a geographical shield built into their playbook. They didn't need to panic and suddenly move final assembly to U.S. dirt because they'd already been bolting flagship LEXION combines together at their Omaha, Nebraska plant since the old Caterpillar days. That long-game investment meant Omaha was already standing by as their shield against whatever trade war or supply chain nightmare hit next. Front 2, the hot swap myth. There was talk that engineers could just hammer out code to let the machine's electronic control units hot swap between chip brands right on the factory floor. Truth is, nobody dodged the bullet completely. When the main suppliers choked, you couldn't just hot swap a tractor's brain to a gaming chip from NVIDIA or AMD. Like everyone else, CLAAS took the hit, watching the assembly belts in Hlavínka grind to a halt for weeks at a time. The real pivot wasn't a magic software fix. It was brutal ground-level logistics, stockpiling whatever silicon they could scrounge to finally get the belts moving again. Dealers who complained about the Hlavínka lawsuit suddenly got the picture. A manufacturer that completely fails to deliver loses dealers. A manufacturer that fights tooth and nail through a global crisis to get the iron flowing again, they write the rules. By early 2026, those rules were shifting again. This time, the fight went deeper than software or supply chains. The literal fuel burning inside those massive 15.6-liter blocks was about to become the new battlefield. Two fronts opened in 2026, and CLAAS fought on both at once. The real engineering war in agriculture right now isn't over horsepower or cutting width. It's over what fuels the beast. CLAAS is running their big iron on HVO, hydro-treated vegetable oil. It's not the obvious move. The rest of the industry spent years chasing battery electric propulsion and hit a brick wall. Slapping a battery pack big enough to push a 400 horsepower tractor through a 12-hour harvest adds thousands of pounds of dead weight. That crushes the soil and kills long-term yield. CLAAS went the other way. Instead of fuel cells, they use a sustainable liquid drop-in fuel. They didn't just magic this out of thin air. They took the proven 8.7-liter FPT Cursor 9 block and just pumped it full of refined waste oil. You still get the roar of an engine, the immediate throttle response, and that gut-level lugging power through heavy mud that batteries just can't fake at this scale. The fuel comes from biological waste, closing the loop. HVO drops right into the existing tanks, leaving lithium batteries looking like expensive boat anchors. The weight penalty disappears, and it slashes carbon by 90% right out of the exhaust stack. It's a total shift in how a machine works in the dirt. At the same time, Chinese builders like Loval and XCMG are flooding the market. They're dumping iron priced lower than any European builder can touch. These aren't scrap iron outfits. They are state-backed heavyweights burning cash to buy market share, invading turf CLAAS has held for decades. The market is splitting in two. You've got high-volume Tier 2 machines welded from subsidized steel on one end and a shrinking ultra-premium segment on the other. A private company in Harsewinkel paying for German precision without government handouts can't win a bare-knuckle price war. The math doesn't lie, and CLAAS knew it. Heading into 2026, CLAAS had to decide, fight for the middle or abandon it to focus where price doesn't dictate the sale. They didn't blink. They went ultra-premium. They targeted massive operations demanding maximum throughput and iron that can run autonomously across thousands of acres. They slapped a 15% price hike on the LEXION line. It wasn't just for the steel, it bought access to a service platform with remote diagnostics and constant software updates. People compare them to Maybach now. It fits. Build fewer units, push higher margins, and sell to buyers demanding the absolute ceiling of what a machine can do. The payoff landed at Agritechnica in late 2025. The Axion 9.450 TERRA TRAC took Tractor of the Year 2026 in the high power class. Because it's running that TERRA TRAC half-track setup, it lays all 400 plus horsepower flat onto the dirt, spreading the weight so it doesn't leave ruts deep enough to swallow a work boot. It didn't win on a spec sheet. The DLG testing board already proved their CMOS AI system cuts fuel burn by 16.8% against expert human operators. They've stacked on predictive driveline management with auto-load anticipation. When the sensors read a hard patch of clay ahead, the system maps the load and instantly commands the ZF transmission to spool up before the engine ever feels the drag. It shifts the power delivery faster than a human brain can fire synapses. All that data feeds into the CBIS terminal in the cab. Cold, hard code now beats the best veteran in the seat. CLAAS has chased this kind of integration since 1968, when Dr. Walter Brenner first argued the future of harvesting was information, not just heavy iron. They're pulling it off while still fully family-owned. When John Deere took a hit in early 2026, Wall Street dictated their reaction. CLAAS doesn't answer to that clock. Katrina Klaas-Muehlhauser can eat the short-term burn of a 15% hike, a massive HVO fuel pivot, and a Nebraska plant expansion all at once. Why? Because she doesn't have to justify the sweat and spending on a quarterly earnings call. That structural advantage goes straight back to 1921, when August CLAAS walked into a patent office with his design for the legendary Knotter mechanism, a piece of iron so perfectly engineered it practically built the company overnight. Patent 414212 still works. Deep inside a 2026 quadrant baler, buried under load sensors and humming data lines, that mechanical billhook keeps spinning. It feels the drag in a dusty crop bundle, shifting its steel grip on the fly to tie a dead solid knot. It's doing it in a fraction of a second, fighting back thousands of pounds of compressed straw while the plunger slams at 51 strokes a minute. The real magic of the design? It ties a clean loop without spitting out loose twine tails. No leftover offcuts means no stray string ending up in the feed trough to choke cattle. The metal is tougher than in 1923 and tolerances are razor thin, but August CLAAS's geometry hasn't changed. It didn't need to. August built this jaw-to-handle cheap, sloppy sisal twine. Today it bites down on high-tensile plastic carrying over 500 pounds of knot strength, and it doesn't skip a beat. A jaw that flexes with the load instead of fighting it is good engineering. Good engineering doesn't expire. Any operator will tell you, if that billhook gets a speck of rust or a burr, it holds the twine and snaps it. You keep that steel polished like a mirror, or you're going to be climbing out of the cab. CLAAS has stamped out over 1 million knotters. They run AI throughput, HVO burning blocks, and autonomous rigs across thousands of acres. The anchor holding that high-tech iron together is a simple billhook, yanking a piece of rough twine.